why do we sample? Why don't we just survey the entire population? And a great example is the 2000 census. Bill Clinton argued that attempting to do an entire population count undercounted certain groups. Actually, by trying to survey the entire population, we undercount certain groups. A couple good examples of that are homeless people. You know, if we're going door to door making sure people fill out their survey, well, homeless people don't have a door, so they're impossible to survey. You also see issues in ethnic minority communities, where you see Latinos, for example, often have language issues where they don't speak English, and so survey takers can't help them, or can't not help them, but can't speak to them and can't ask them questions in English. You'll see perhaps undocumented immigrants less likely to answer the door for government officials. All these sorts of issues where rich people tend to answer the door, poor people tend not to. You undercount certain groups. Sampling is actually more effective in certain circumstances than trying to get the entire population. The second argument is that sampling is cheaper, and this is the big argument, right? You know, I could try and survey all 300 and something million Americans, or I could sample 1,500 Americans and get a reasonably close estimate of the entire population mean. It's much, 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 much cheaper and much, 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 much easier to sample. And the last point here, sometimes collecting the entire universe, the entire population, isn't possible. There's some great work on campaign ads, campaign emails, things like that out there in the academic literature where you'll never collect everything. It's impossible to collect everything. And so if you do a systematic sample, it ends up working better and it's more efficient for a number of reasons. So this is why we sample. It's easier, it's cheaper, it actually in a lot of cases performs better, and sometimes it's just not possible to do the entire population. Think about doing a public opinion survey if you're trying to figure out, do people like President Obama? You know, could you survey all 300 million Americans, or let's say all 200 million Americans over the age of 18, whatever the number is? No, there's no way you could do that. By the time you did it, it would be I don't know how many years, and you wouldn't have a meaningful idea because you surveyed some people, 2009, and by the time you finished, it was 2011. Obviously, people's opinions had changed over that time. The numbers would be meaningless. We sample because it's easier, it's quicker, it's cheaper, and a lot of times it's just better. So we're going to talk about some different types of samples here. And there's probability samples and non-probability samples. There's systematic, there's random, there's all sorts of good stuff here. And the point is to think about the strengths and weaknesses of each of these ideas, when they could be used, and what sort of inferences we can make from them. These are good to know, by the way, for the exam and for life, so make sure you really focus on this part. The first type I want to talk about is a simple random sample. And what this means is that all units in the population have an equal chance of being drafted. The prototypical example here is just drawing numbers out of a hat. You just pull people out of a hat and you get a random sample. Everyone has an equal chance of being drawn. I put every student's name in a hat and I start pulling pieces of paper out, and those pieces of paper correlate with who you are. More modern way would be computer-generated random numbers. You assign everyone in the population a number, and you draw those numbers, again, out of a computer simulation rather than a physical hat. The simple random sample means everyone in the population has an equal chance of being pulled. And this is important if we want to make inferences. We need that randomness. Randomness is the key to making good inferences about an entire population. The next type here of probability sample, and it's very similar to the random sample, is a systematic sample. And the definition is you draw every jth member of a list. What does that mean? It means if you have 5,000 names, you only need 100 of those people to survey. Then you go through and pick every 50th name. So you start at a random spot in the order, and you pick a person, and then you go 50 slots down, and you need to go that person too. 50 slots down, pick that person. 50 slots down, pick that person. This is basically the same as random sampling. Everyone has an equal chance. It just depends on where you start. But it's an easier way than assigning random numbers to everybody and jumping around a lot. You just go from every 50th name, and you call people.